This video lecture is a continuation for Hurricane Exercise Part 3. The previous video lectures we went over how to work with the hurricane damages and deaths data, specifically on looking at initially nominal damages, nominal dollar values, and turning them into real dollar values, 2017 dollars. And then we calculated the summary of statistics, which included the expected damages and deaths, which required us to compute the recurrence interval and exceedance probability. One of the things that we noticed when we were looking at this data is that the mean and median values are very different, which means that the data is likely very skewed. It's not normally distributed, and the significance of that on one level is simply that the mean can't be counted on to be representative of the data. So it's not a typical data value. But it also makes it harder to understand how our data is distributed. And what I mean by that is, if we're trying to get a sense of, for example, with deaths, are there a lot of years with few deaths and a few years with a lot of deaths, or are there a lot of years with a high number of deaths and then only a few years with no deaths? Like, how does it occur from year to year? And so to understand that, we have to construct what's called a histogram, which is basically a graph, a bar graph, that shows us how often certain numbers occur. So for example, how many years do you have no deaths? How many years do you have 100 deaths, right? So to build a histogram in Excel is a little complicated, unfortunately, but I'm going to walk you through that. If you're working with the online version of Excel, unfortunately, there's no direct add-in comparable to this, so this part will have to be done separately in a different way, and I will help you through that if you need that help. So in Excel, for the desktop application, to enable the option to do histograms, we're going to have to go to the File menu up top and then choose Options in the lower left. And then in the left-hand column here, we click on Add-ins. And in the middle, under Inactive Application Add-ins, we're going to click on Analysis Tool Pack. That's the one that we're going to enable. And then we're going to click on Go at the bottom. And then in the add-ins window that pops up, we're going to choose Analysis Tool Pack and hit OK. And nothing apparently happens, but if you click on the Data drop-down menu up top and you look at the far right, you'll see this option for data analysis, and that was not there before. If you click on that, it'll show you a variety of statistical tools and tests that you can do that aren't otherwise available. So we're interested in the histogram, but we're not quite ready to do it yet. So we'll hit cancel for the moment. And in order to build a histogram, we're going to have to create what are called bins. And essentially, these are instructions to Excel on how to break up the data and how to build the graph. So I'm going to create a column here called death bins, not to be funny. And these bins are going to basically define the ranges for each column in the graph. So the first one, we want to break it up, let's say, into 10 equal ranges. So we want to take the numbers of deaths that are possible, right, which we know range between 0 and 8,000. And we want to break it up into 10 equal intervals, right? That's how the graph will be organized. So the easiest way to do that is to take the maximum value in our data set, which we know what it is, but let's just take it from the data directly. So I'm going to take that range of data to find the max value, which will be 8,000, I know, and divide it by 10. And so that gives me the value of 800. And I did it that way because now I can take that number and simply add 800 to it, right? Because I'm going by increments of 800. And I can keep copying that formula down, and it keeps incrementally adding 800 to it, and I'll do that until I arrive at 8,000, which is the highest possible value in our data set. So now with those bins defined, I can create my histogram. So under the data menu up top, I'm going to choose data analysis in the far right corner, and the window that pops up, I'm going to choose histogram, hit OK, and it needs two things. The input range is the actual values, so in this case deaths, so I'm going to click on that, and then I'm going to highlight the values in the deaths column. And so what that's going to do is it's going to say, okay, take those values, and then we're going to build our histogram out of those values. So we'll go all the way down there, hit enter, and then the bin range, which is we just created, which is up here. Let me scroll up a bit here. All right, so the bin range are these values. So I highlight those, hit enter. All right, and it's going to put a new sheet for us, which I want, and then I want it to be cumulative percentage, and I want a chart output. I don't want the Pareto, cumulative and chart. So I hit OK, and very quickly it generates a new sheet with a table and a graph. So let me expand that graph so we can take a look at that so we know what we're talking about here. All right, and so what are we looking at? All right, this is a bar graph, all right, but it's a histogram. So the first bin, right, this column, represents the number of years in which there was between 0 and 800 deaths. So if you hover over it, you can see the number. It says 116. So there are 116 years in which there were between 0 and 800 deaths. And you can see that over here in the table too. So that you get the bin, which again, the number here represents like the ceiling of that range, 0 to 800, 116. The next one, 1600, is from 801 to 1600. So it represents the next kind of range or increment. And there was 1 year in which there was between 801 and 1600 deaths, right? We don't know exactly what that number was. We just know it fell in that range. All right, so that's what these numbers mean, these frequencies. And those numbers are displayed here on the graph by the height of the bars. They represent the frequency. And you can see on the far end over there, 8,000. There was 1 year in which you had 8,000 deaths, right? And you see that reflected over here too. Now, the cumulative percentage, which let me expand that a bit, it's a little different. So that's shown here with the orange line. Now, the cumulative percentage grows over time. So in the first year, you can see that there were 116 years with between 0 and 800 deaths, and that represents 96.6% of all the data of all the years, right? When you move up to the next one, there was 1 year in which there was between 801 and 1600 deaths. Now, when you add that one more to the data, it grows the total amount that this represents to 97.5%. So these two numbers represent 97.5% of all the data. As we move further down, right, there were no years in which there were between 1601 and 2400 deaths, but there were 2 years when there were between 2001 and 3200 deaths. And so then these numbers represent 99% of all the data. So you can see how that cumulative percentage grows. So you can see at what point you cap out, right? So by the time you get to 8,000, you're representing 100% of all the data. So what does this all tell us? Well, what it tells us is that the vast majority of the data falls within that first column, right? So the vast majority of years have between 0 and 800 deaths, right? Which is good to know. But it also means that a lot of what's going on is hidden from us because we don't know within that column what's happening, right? Like, does that mean that most years have no deaths, few deaths, 600 deaths? Like, what's going on in there? So in order to get at that information, we need to break up this graph a little bit, or break up the histogram into different bins, right? We organize this differently. Now, the problem is that the data is very skewed, right? We see how it kind of stretches out to the right. And this skew is defined as a positive skew, or it's right-handed skew, because it has a long tail. We have one really large number on the far right, which is kind of pulling everything out. But in reality, all the data is really bunched up over here on the left. If it was the opposite, if it was negatively skewed, we'd have one small number. We'd have very few small numbers and a lot of big numbers, right? But we have a positive skew here. So to get a sense of what's going on here, let's reorganize our bins a little bit. So let me rename this sheet first so I don't get confused. So I'm going to call this the death hist. And going back to my data, I'm going to build a new set of bins under here. And just like before, we've learned that exponential values, or log values, which are their inverse, are a good way of breaking up data when you've got a huge range of data where small numbers are getting hidden. So I'm going to create essentially bins that grow by powers of 10. So I'm going to start, the first value will be 0, of course, and then I'm going to grow it in powers of 10. So I could just write 10, 100, 1,000, but I want to just kind of use a formula here. So I'm going to grow them by powers of 10. And so instead of trying to type in the number with all the zeros where I might make a mistake, I'm going to take 10 to the power of this number. So 10 to the power of 1 is 10. And then if I copy that formula down, it's going to say 10 to the power of 2, which is 100, and so on. So then by the end, I get to 10 to the power of 4, which is 10,000. Again, could have written that out, but this just ensures I don't accidentally add or remove a 0. So with those bins set up, I can recreate my histogram. So I'm going to go to the data menu up top, and I'm going to choose data analysis. Again, making a new histogram. Hit OK. The input range is the same because I'm using, again, deaths, but the bin range is different. So I'm going to remove that, and I'm going to highlight these cells right here and hit enter. Same options here, new worksheet, cumulative percentage, chart output, and hit OK. And when I do that in the new sheet that I create, you'll see something really interesting. Now the data has been pulled out. It looks a little more normal. It's still got a little bit of a skew to it, but it's definitely got more of a bell shape to it. But what's important for us here is we can see more detail now. So we can see, for example, that the years when there was 0 deaths, right, represent a not insignificant number of years. So we're 19 years, and they represent about 15.8% of the data when there were no deaths. What we see a lot of the activity, though, is in the 10, which is 10, which stands for 1 to 10, and 100, which stands for 11 to 100, right? So in that range, we see that a lot of the data is represented. So how do we read that? Well, we know that this number right here, 50%, represents these two numbers, and this number, 84%, represents all these three numbers, right? So if we wanted to understand, like, what does this number, what does 41 represent apart from those first, that first bit, we basically would subtract these two numbers. So for example, 41, right? So the years in which there were 1 to 10 deaths, right? If you want to know just what that percentage represents, you'd say it's 50% minus the 15.8 over here, right? So we'd say it's about 34% of years have between 1 and 10 deaths, right? But otherwise, the 50% represents these two sets of numbers, right? So you see how the cumulative percentage work. It gives you a sense of what proportion of the data that those numbers represent cumulatively, or if you want to, you can separate them out. So what we see now is we can get a sense of how the data is distributed. We can see that most years have either small or moderate levels of deaths, and only a few years have really high numbers of deaths, right? So this gives us a better sense of what goes on year to year. So now your turn, you're going to do the same thing using the damages data, looking at the histogram of the original data, and then trying to do the same thing, but using powers of 10 to see how it changes the data to allow you to see what's going on with the smaller values.